Hello, good morning, and thank you for joining me in my shop on today, which is February 23rd. And it's not quite so cold out anymore. Now it's just a little bit below freezing. And I've got a trip to the grocery store coming up this morning. And the weather report is blah. It's just kind of gray today. So big snow appears to be over. Big snow still out there though, because it's been below freezing. It has not gone above freezing now for quite a few weeks. So okay, so we're into the home run now, or the last stages of doing the calibration on this unit, and things have gone fairly well. I have it already set up for the next stage. You can see I've got my ammeter here. This is set up to be an ammeter, and it's plugged into these two jacks as instructed in the instructions. And then this has to be set up for an EM test of the L6 that's in there, so that's something I've got to do. So I hadn't done that. Give me just a moment here, and I will whoops. He says whoops. Bah. Maybe I shouldn't have hit go on the video so soon here. I'm just looking for the instructions for diagram C, I believe it is. Let's see. Below, yes, C. Okay, so here we go. So this is on B. This is set to EM to trigger the EM test. This is set to B. This is set to D. And this is set to 0. Oddly enough, of course, we're not trying to measure the tube. We're setting up for a calibration test here, so this is not a normal 6, 8, 3, and 1. Okay, and down here 0, 5, 2, 4, and 8. Now these last two, this one in particular, doesn't affect the tube that's under test directly. It's a call it an auxiliary control. It does different things and causes different voltages to be presented to the plate here, I think. And this one has something similar going on too. So I'm not exactly sure, but setting this to 4 and 8 is probably what's creating the opportunity to measure current through these two terminals. That's probably what's happening. Okay, so we have it set up now, and the next instruction is turn instrument on and allow 30 seconds of warm-up. Adjust bias potentiometer for 20 milliamps of plate current on the DC milliammeter. Without changing any settings, adjust potentiometer P11 on the power supply chassis for a reading of 3 on the 10-volt bias scale of the tube tester meter. For a reading of 3, so that's somewhere in this area here. Okay, I think I got the idea. Turn instrument on. There we go. It's not often I use these meters as ammeters. I'm probably true for everybody who does this kind of work. So using it as an ammeter puts the meter at a bit of risk. Actually, I don't know how much risk there would be with this. There's a fuse in it, but hopefully we won't find out. Okay, and nothing's happening on this meter. So I'm guessing we should adjust the line, although it didn't say that. Why would we even want to try it? Let's read what the next instruction is. Just leave everything as it is. Okay, turn the instrument on, allow 30 seconds. Adjust bias for 20 milliamps of plate current on the DC milliammeter. Oh boy, really? I don't see any current on at all. Perhaps this has to be set on. Did I miss that one setting? Let me just check quickly here. I may have missed something. Yes, I did. I should be on hold. Okay, that explains that. Oh my gosh, what's happening on my computer here? Okay, I'm having trouble with my computer. So we'll put this on hold, and we get a current here. And look, it's very close to 20. Now we're supposed to force this to be 20. Wasn't that what we were supposed to do? No, I've messed up my... the computer I'm reading the chart on, it's all gone crazy here. 20 milliamps. 20 milliamps. Adjust a bias potentiometer for 20 milliamps. Very good. Okay, well, we're not going to get much more accurate than that. 20 milliamps. And the next thing is adjust potentiometer P11 for a reading of 3 on the 10 volt scale. Oh, I gotta tip this back now. What happened here? That's right, I'm not paying attention to this. Okay, so somehow this has gone a little bit higher. Maybe I bumped something, who knows? Or the house voltage is changing. 20 milliamps. Okay, there's 20 milliamps there. And we want to adjust P11 for a reading of 3. It's way up here. It should be way down here. P11. Okay, I need an instrument, a tool. I got it. 3. 3 on the 10 scale. Three on the 10 scale. Okay, that's good. That's it for that. Excuse me. The next thing is filament current calibration. Okay, we'll attend to that next. The next step is really pretty simple. So it's believed the current draw on the filament of a 6L6 is 0.9 milliamps. Using that as a standard, you're to calibrate this meter while reading the current flowing through the filament. So let's see, rotate test switch to off. Remove test leads from here. Rotate meter switch to line and adjust for center scale reading. Oop, not with that control. Okay, here we go. I'm listening to my computer chugging away down below. Kind of wondering why it's chugging so much today. Right. Rotate meter switch to 3 amp and adjust P12 on power supply chassis for a reading of 0.9 on the 3 filament amps meter scale. Rotate meter switch to 3 amps. There we are. There's nothing up here. Nothing. Wait, oh, there's more. Rotate meter switch to 3 amp. Adjust P12 for a reading of 0.9 on 3 filament amps meter scale. There's nothing at all. Maybe it's because I haven't adjusted this at all. What are we adjusting? P12. P12. Okay, P12 is over here. Make P12 read. Get my hand too close to things here. Okay. Will you read something? There we go. Okay, so it's supposed to read 0.9 on the 3 scale. Yeah, we can't do 0.3 scale. That's not good. So 0.9 on the 3 scale, way up here. Oh. My computer's making the identical chugging sound over and over and over and over, as if it's caught in some kind of, I don't know, hard drive process. Anyway, okay, so that's done. So this is reading now point. It's jumping around a bit. Just knock it back a little bit here. This is where you get. You see, this is where you get the injury. When you carry out a process and you finish the process and you go, oh, I forgot something, you're not liable to be thinking very detailed about what you've been doing. You're likely to think about the thing you've forgotten and make a move which causes a accident or injury. So anytime you hear somebody say, oh, I just forgot something, slow them down, especially if they're working with electricity. Okay, so that's good. There we are. And what's left? I think there's only one thing left, isn't there? What's left here? Remove the 6L6, rotate switch something to 5 and switch 1 to 6. Make certain test switches in off position. Well, shouldn't you do that right off the bat? Put test switch into off position. It is off. The filament switch should be at 6.3. Insert the 6C4 tube. Rotate meter switch to line. Adjust for center scale reading. Rotate meter switch to 0.3. Adjust potentiometer P13 on the power side for a reading of 0.3. So we've got to do a calibration on the 0.3 scale using a different tube. So that tube will be screaming hot at this point. So I'm just going to stop for a little bit. In fact, this might be a good time for me to run out to the store. Yeah, I think I'm going to do that. I'm off to Costco. Then I'll do the last step. Great. Okay, so I'm back from the grocery store, and time to do the next step. The next step involves using a 6C4 tube, and let me just review the instructions here quickly. So remove the 6L6 tube, rotate switch H to 5. Let's see, switch H to 5 and switch I to 6. Okay, that's been done. Make certain test switches in the off position. Test switch off position. Filament switch should be at 6.3, which it is. Insert the 6C4 tube. I did. Rotate meter to line switch, and okay, start her up. Start her up. Here we go. Give it a few minutes here. Let's read the rest of this. Adjust P12 on the power supply chassis for a reading of point. Oh, that's the wrong one. That's the wrong one. Down here. Rotate meter switch to 0.3 amps. Adjust potentiometer P13. P13. Way up there. Okay, P13. And you know what I think I did? I think I accidentally adjusted P3. I bumped it. I think I bumped P3. Uh-oh. Wow, that's not good. I gotta take a look into what to do about P3 now. Okay, here we go. Insert the 6C4 tube, rotate meter switch to line, adjust for center scale reading. The thumping and banging are my cats next in the laundry room next door, playing around. In case you're wondering. This is difficult to read. The filament switch should be set same line of center. Okay, rotate meter switch to 0.3 amp. Adjust potentiometer P13 for a reading of 0.15. That's the assumption that this is drawing the correct current doing this. So what did it say we do? Rotate meter switch to 0.3. Rotate meter switch to 0.3. That's 0.3. And adjust P13. Okay, here we go. And we want to bring this up. We're on the 0.3 scale, 3 scale. 0.15. Whoa. No, 0.15 would be half, wouldn't it? Wouldn't it? If we're on the 0.3, 0.15 would be half. Be up like this. Why so jumpy? Something funny in the... Oh, I'm right at the end of the control. That's why it's behaving weird. Watch your hand, Jim. You're going to get a shock. I know you can't really appreciate what I'm doing, but it keeps dropping right in the spot where it needs to go. Let's put it right here. This is about as good as we're going to get. Whoops, right there. That's no. I gotta jump around, eh? It's right on the money now. It's perfect. Okay, so that's a calibration of the current. Right, so 0.3 would be 300 milliamps, 150 milliamp draw, should put it halfway up. That makes sense. On this scale, 3 amp, it's just barely up. That makes sense. We're good. We're good on this. Where am I at now? 0.3 amps of scale meter. The same note applies to this adjustment as applied to 6L6 regarding the use of an AC ammeter. What? Huh? What? You have now completed the calibration of your Model 3. Have I really? I don't have a really good feeling. I have a feeling that, well, we got to test some tubes in this thing to find out if we really got it good or not. Okay. Yeah, maybe I'll give the 6L6 both tests, and we'll see how it comes out. Okay, you can see the chart up in the right there for 6L6. It's right in the middle. Let's go through the whole thing properly here. So 6.3 volts, 6.3 volts. B, G, G, G with a dash. B, G, G, G. Doesn't matter. This last one. Next row is 2, 6, 4, 3, 1. 2, 6, 4, 3, 1. Okay, and then the next one is 0, 5, 2, 0, 0. 0, 5, 2, 0, 0. Okay, very good. We can pop the tube in now because we have 6.3 on here. Okay, we'll give it a moment. First thing we need to check is the, would we not do a short check right away? Wouldn't that be the first thing? I would think that's the first thing to do. So I'm going to do that first. I'm not sure that's how the instructions read, but here we go. Short on 2. Short on 7. That's perfectly normal. Okay, now we'll check the line. Line's a little low. Adjust that up. Okay, now the bias up on the chart there, bias is 2.9 volts. So we'll go bias, and we'll set it to 2.9 volts. So we're on the 10 scale. 2.9 volts would be right about here. Okay, flip this back to test. We'll now look at the current flow. So on the 3 scale, current flow is it shows 1 amp. It's supposed to be 0.9, so it's slightly high, but that's probably just inaccuracy in the meter. My calibration work. Okay, now have we done everything? We've done everything, so we're ready to test. So looking up at the chart again, it's the reject point is 3825. So we're on the B scale, on the 20. We're on the 20K scale. So we're on the top scale, and the reading we're looking for again. I'm gonna look up at the chart. 3825. So on the top scale, 3825 is only up to here. That's not very high. I prefer it to be up in here. Okay, so we're in test. Well, it's come right to the spot I was pointing to. So in reading this now, this would be 3400. 3400. Now, wait a minute. This is way off from the other readings. The other readings are 26, 25. Wait a minute. No. Read up here. Well, you can see what they were here. They're all up in the 5,000s, you know. And this column here. That's from previous tests. This is the tube we're testing. Number 2 here. 5,200, 6,000. So again, looking at the chart, 6L6, it says the reject point is 3825, which doesn't relate at all to these numbers. Okay, so just relying on the tube tester's own values, which is the way you have to do it. 3825, and we're reading, 3400 instead of 3825. I don't get it. Isn't this supposed to be telling me the actual transconductance of the tube, as it would be if it were normally operated, which has got to be somewhere up in the range of 5,000. 3800 is the reject point. It's 3800 is the reject point. So this is saying reject this tube. Oh. Okay, let's do the other test. Now, do I have to pull the tube out to do the other test? I don't think so, because these buttons remain the same, and only these ones change. And these probably only do something when you push this in. Take that off. When you leave that on, don't leave that on. So we'll set it up. So yes, those are 2 cats running around here. What are you doing, guys? They're behind the door now. Hey, come out here. No, they won't come out now. Oh, here they come. Bert. They don't know their names. They never will. Bert. There's Bert and Wally. There they are. The trouble pair. Yeah. What are you doing? You're getting tired out, aren't you? Worn out? Playtime's coming to an end, I think. I think they're getting worn out. I know I'm getting worn out. Okay, my life of distractions. So we're going to set this top row now. So looking up at the chart and picking the EM test line. BEBD8. That's what I see up there. I'm going to look at my... That's a little hard for me to say. BEBD8. A little easier if I look at my own computer screen here. So we go B, stays the same. We switch to the EM test. We go B, D, and we we set this to 8. Oh, you smell? Anybody smell anything burning? Someone's getting a little warm here. Is it these transformers? No. No, they're not hot. I don't know, maybe it's just the tube getting hot. Yeah, something doesn't smell quite right. Okay, just ignoring the potential for a house fire and continuing along. I set this to 8. Okay, then that's it. We're ready to do the test. The bias, what's the bias supposed to be in this case? Oh, okay. Ooh, those cats are destroying my house. 14. Hey, what's going on here? Oh, you know what? They're playing a game. They're playing a cat game called I Got It, You Can't Have It. Hey, what's all the hissing? Come on. Oop, where are you there? See what he's got? You can't have it. Okay. There you go. Ooh, he's growling at me too. He brings it over to his brother and growls at him with it. I don't know if you can hear that or not, but there they go. I'm chasing you with it. He's not playing the game right. It's the guy without it who's supposed to do the chasing, not the guy with it. Well, I don't know if they really studied the cat rule book or not. Okay, so getting back to this now. Everything is set. We're ready to do the test, and oh yeah, the bias. I was just setting the bias. 14 volts. So we'll put this like that. And we'll put this like on line, and we'll make sure it's correct. It's good enough. We'll go here, and we'll dial this thing up to. Uh-oh. 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 Where'd the bias go? What happened here? Uh-oh. The bias quit. Does it have to be on? It has to be on. It has to be on. No, it's not. What's happened? What's happened? Bias. Off. Test. The tube's hot. Something not working. You know, I flipped this to EM and then I started talking about something cooking. Uh-oh. This is not good. What to do quickly. Okay, make absolutely sure the bias thing is not doing anything. Okay. Could be something set wrong here. Power off, power off, power off. Okay, we're going to leave it like that because it's late in the day now. And tomorrow I will pursue this issue, whatever the heck it is. And I'll bet you somehow my cats are responsible. Thanks a lot for watching, and have a great day, and we'll see what happens tomorrow, because I'm really close now to getting this thing working reliably and make it trustworthy and all that kind of stuff. I'm close. See ya.